All right. Uh, so today I'm gonna be discussing the traveling salesman brute force exhaustive search algorithm. So first off, my name is Eli Parker. I'm a now a math major and with a concentration in statistics with a computer science minor. Um, I chose this algorithm because one, it is pretty simple, two, straightforward, three, I like to travel, so traveling salesman just goes with it, but necessarily not that I want to be a salesman. So the problem that this algorithm solves is finding the shortest sum between values. Like if you're taking a trip to different cities, say you start at one point and you want to get the shortest distance between three cities and come back to your starting point, you want to go through this process and see which sums of distances will be the shortest to optimize your travel time, and it would definitely help you on your gas or maybe your uh, plane tickets and such. And the algorithm design technique used here is literally in the name, brute force exhaustive search. The brute force just means it is the simplest way to solve a problem up front, with the exhaustive search being for the combinatorial problems. So, how the exhaustive search section goes is you will generate all permutations. Rule 2 is only using permutations that satisfy constraints, and 3 is selecting the optimal values, aka possibly like the shortest distances to travel, or the paths you want to take to travel short distances from your one city to these three other cities back to your city. And time and space efficiency is O of n factorial. This is based on the number of permutations, because the input size would be the number of cities in the figurative graph. Um, so let's say I'll give it kind of an example. So you have, I'm gonna draw this out too. So say you have city one, you have city two, and you have three. Excuse my horrible writing, but you have four, right? Uh, how you're gonna calculate the n here is you're actually gonna, like, since you're gonna go from starting point, say you're going from starting point, and then to these three cities, maybe you'll go like from these, through the middle. You're gonna do n minus one, so n minus one. You're gonna do n minus one, which is you go 4 minus 1, which is 3 factorial. So you're going to do 3 factorial, which is 3 times 2 times 1, which is 6. So your time and space efficiency here would be O of n, which is 6. The n factorial, sorry. Okay. And to give a real life example of the traveling salesman brute force search exhaustive search algorithm, I'm gonna like give an example problem of something that would actually help me out. So say I start from my house and I have errands to run, as a casual person will have. So I have to travel to Kroger to grab groceries, but I'm also feeling hungry. So I'm going to go to McDonald's, right? And then at the same time, my hair is a little long. I'm going to want to go get a haircut. So go to the salon, haircut box. So I'm going to So we have to know the distances of between these places, right? So we say my house to Kroger is 5 miles. And we say Kroger to the haircut place is 2 miles. But Kroger to McDonald's is 3 miles. Haircut to my house is going to be 7 miles. And the haircut to the McDonald's is going to be 4. And the McDonald's to my house would be 6. I'm just putting random numbers, but you get the idea. Here, we're going to find, so your factorial is going to be the same as this previous example. You can do, n minus 1, which is 4 minus 1, and then you factorial that, so 3 factorial. It equals 6 because 3 times 2 times 1. So we need to lay out all the permutations. There's going to be 6 of them. So we're going to lay out. Yeah. So we're going to start from my house. We're going to do my house to Kroger to the salon or haircut to McDonald's back to my house, which is take the path 5 plus 2 plus 2 plus 4 plus 6, which equals 17 miles. And then house to Kroger to McDonald's to haircut to my house is 5 plus 3 plus 4 plus 7, which is 19. Then we'll go to haircut first, go to McDonald's, then go to Kroger, back to my house. So we're going to go 7 plus 4 plus 3 plus 5, which equals 19. And then we'll do start from house, haircut to Kroger to McDonald's back to my house, which is 7 plus 2 plus 3 plus 6, which is 18. Then fifth permutation would be house to McDonald's first, then haircut, then Kroger, then house again. So that would be 6 plus 4 plus 2 plus 5, which comes out to 17. And then last permutation would be house to McDonald's to Kroger to haircut back to house. Should be 6 plus 3 plus 2 plus 7, which is equal to 19. And then we would take these two paths in the end because they're the shortest two paths of 17 total miles. And that is the entire point of the Traveling Salesman Brute Force Exhaustive Search Algorithm. Thank you.